Okay then. Number 2. The position of a particle moving the xy plane is given by the parametric equations x of t equals t cubed minus 3t squared and y of t equals 12t minus 3t squared. Which of the following points x comma y is a particle at rest, right? So this question is asking us to find where the particle is at rest, right? So we know a particle is at rest, but its velocity is 0, right? But these two functions given to us are in terms of, are for the position, right? So to find the equation for velocity from position, we need to take the derivative, right? So x prime of t equals 3t squared minus 6t, and y prime of t is equal to 12 minus 6t, right? So then we also now we want to find what time the particle is at rest, right? So we gotta, and when the particle is at rest, velocity is 0. So that means 0 equals 3t squared minus 6t, and 0 equals 12 minus 6t. So now we just want to solve each side for t, right? So here we can factor out a 3t, so 0 equals 3t times t minus 2, and here 6t equals 12, and then t equals 2. And on this one, t is equal to either 0 or 2, right? So now we know that the particle is at rest when time equals 2, but the question is asking us to find which of the following points x comma y is at rest, right? So we have a, negative 4 comma 12, b, negative 3 comma 6, c, negative 2 comma 9, d, 0 comma 0, or e, 3 comma 4, right? So now we want to plug in time of 2 back into our original equations for position, right? So x of 2 equals 2 cubed minus 3 times 2 squared. Then y of 2 is equal to 12 times 2 minus 3 times 2 squared, right? Right? So now x of 2 equals 2 cubed, which is 8, minus 3, 2 squared is 4. So that's equal to 8 minus 12, or negative 4. And then y of 2 equals 12 times 2, which is 24, minus 3 times 2 squared, which is 4. So that's equal to 24 minus 12, or 12. So in other words, our point is negative 4 comma 12, or answer choice A, right? Oh, I need to wash this shit. Okay, number 3. The graph of f is shown above for 0 to x to 4. What is the value of the integral from 0 to 4 of f of x dx? Okay, so we're going to have a graph here. We have our x-axis. We have 1, 2, 3, 4, 5. We have negative 1, negative 2, negative 3. Then we have x value 1, 2, 3, 4. So we have 0.2 comma 5. We start at here. Then we have 2 here and down here. So we have this 0.2 comma 5. Then we have this 0.4 comma negative 3, right? And this is the graph of f of x. Now the question is asking us to find 0 to 4 of f of x dx, right? So here we have a, negative 1, b, 0, c, 2, d, 6, and e, 12, right? So this question is just asking us to find the area, right? So we can find the area of this rectangle and triangle, right? So we have a rectangle of height 1 by base 2, so we have a area of 2 there. And then we have a triangle of height 4 and base 2, so that's an area of 4 there, right? because the area of a triangle is 1/2 base times height. And down here, we just have a negative square, well, negative rectangle, right? So this rectangle has a base of 2 and a height of 3, right? But because it's under the x-axis, we know that that area is negative. So then the integral from, so we could also rewrite that integral from 0 to 4 as the integral from 0 to 2 of f of x dx plus the integral from 2 to 4 of f of x dx, right? So know the area from 0 to 2 of f of x dx, which is this triangle and rectangle here, is equal to 2 plus 4, right? Plus this area from 2 to 4 of f of x dx, which is this rectangle under the x-axis, that's negative 6, right? So then we get 6 plus negative 6, or 0. So that means the area is 0, so the answer is B. Okay, so that was 3. Okay, number 4. Which of the following integrals gives the length of the curve y equals ln of x from x equals 1 to x equals 2, right? So we have a integral from 1 to radical 1 plus 1 over x squared dx. B integral from 1 to 2 of 1 plus 1 over x squared dx. C integral from 1 to 2 of radical 1 plus e to 2x dx. D integral from 1 to 2 of radical 1 plus ln of x squared dx. Or E integral from 1 to 2 of 1 plus ln of x squared dx, right? So this is asking us for arc length, right? So we know that to find the arc length of any function, we have a formula, right? Where the arc length is equal to the integral from a to b of radical 1 plus f prime of x squared dx, right? So if we use this formula in here, right, we know our f of x is ln of x. We want to find f prime of x, right? So if f of x equals ln of x, then f prime of x equals 1 over x, right? And they tell us to find it from 1 to 2, so we know our bounds on this integral will be 1 to 2 of radical 1 plus 1 over x squared dx, or the integral from 1 to 2 of radical 1 plus 1 over x squared dx, which is answer choice A. Yeah. Okay, number 5. The Maclaurin series for the function f is given by f of x equals sigma from n equals 0 to infinity of negative x over 4 to the n. Now they want the value of f of 3, right? So they're just, right? So now, so for this, we just want to plug x of 3 into here, right? So then if f of x equals this, then f of 3 would equal to sigma from n equals 0 to infinity of negative 3 over 4 to the n, right? So we could also rewrite this as if n equals 0, right, we would have negative 3 over 4, right? If n was equal to 1, wait, if n was 0, we would have 1, right? Because anything to the 0 is 1. So we would have 1 minus 3 over 4 Then n squared, right? That would be about plus 9 over 16, right? And 3, so minus 27 over 64. So if you see, right, as this is basically the limit as n approaches infinity. So this whole fraction here will be approaching 0, right? So we know that, wait, but that's tough. That's some way. Ooh, okay. Okay, so this would be plus dot dot dot, right? So if we just do 1 minus 3 over 4, right, that's 1/4 plus 9 over 6. Wait, the answer choices are A, -3, B, -3 over 7, C, 4 over 7, D, 13 over 16, or E, 4, right? So now we want to find which of these answers would give us the value of f of 3, right? So we know that eventually this whole thing will be will be equal to 0, right? So we'd be adding 0. So right now we just care about this stuff here, right? So we have 1 minus 0 over 4, which would be 1/4 plus 9 over 16 minus 27 over 64. How does this work though? Okay, we'll get back to this one, alright? Series are not my favorite part of Calc PC. Okay, 6. So we're given this integral -1 to 4 of x times x squared minus 3 to the 5th dx, right? And we're given a substitution u equals x squared minus 3. Which of these following integrals will be equal to this integral, right? A, 2, -2 to 13 of u to the 5th du. B, -2 to 13 of u to the 5th du. C, 1/2 -2 to 13 of u to the 5th du. D, -1 to 4 of u to the 5th du. Or E, 1/2 -1 to 4 of u to the 5th du. Right? So here we just want to do a simple u sub, right? So we want to take everything in terms of x here and put it in terms of u, right? So here the bounds are in terms of x, and then this is all in terms of x, and so is the dx, right? So let's start with the bounds, right? If the x is -1, so u is equal to x squared minus 3, right? If x is -1, u equals -1 squared minus 3, right? So u is equal to 1 minus 3, or equal to -2, right? And then also u is equal to 4, so u is equal to 4 squared minus 3, right? So u is equal to 16 minus 3, or 16 minus 3 is 13, right? So we know our bounds will be -2 to 13 of our integral, right? 2 to 13. And then next we know this will be a u to the 5th, right? And then we want to find dx, right? So if u equals x squared minus 3, we can take the derivative of u with respect to x, right? So du over dx would be equal to 2x, right? Or in other words, du equals, well, 1 over 2x du equals dx, right? And now we want to find an equation for x, right? So if u equals x squared minus 3, then x equals radical u plus 3, right? So then next we can replace this x here with this u, right? So then we'd have 1 over 2 times radical u plus 3 du equals dx, right? Then don't forget we also had an x here, right? And if we know x is equal to radical u plus 3, so we have u to the 5th times radical u plus 3 times, right? Because this is x squared minus 3 to the 5th, this is u to the 5th, and this x is radical u plus 3, and then our dx is now 1 over 2 times radical u plus 3 du, right? So don't these radical u plus 3's cancel out? And so our integral will be, and this is 1/2, that's a constant, right? So we can factor that out. So we have 1/2 times the integral -2 to 13 of u to the 5th du. Or in other words, answer choice C, right? Okay, number 7. If arc sine of x is equal to ln of y, then dy dx is equal to question mark, right? So we're given a y over radical 1 minus x squared, b xy over radical 1 minus x squared, c y over 1 plus x squared, d e to the arc sine of x, or e to the arc sine of x over 1 plus x squared. Okay, right? So dy over dx is the same thing as y prime, right? So don't we want to just take the derivative of this side? So then derivative of arc sine of x, that's a trig identity, and that's 1 over radical 1 minus x squared, right? And then derivative of ln of y is 1 over y, right? Times dy dx, right? Because don't forget, we're taking derivative with respect to x, so we need to include dy dx when we take derivative of y. So if this is dy dx, don't we want to find this by itself? So to get this by itself, why don't we just multiply both sides by y? So we would get dy dx equals to y over radical 1 minus x squared. Or in other words, answer choice A. Okay, number 8. A tank contains 50 liters of oil at time t equals 4 hours. Oil is being pumped into the tank at a rate RT, where RT is measured in liters per hour and T is measured in hours. Selected values of RT are given in the table above. Using a right-Riemann sum with 3 subintervals and data from the table, what is the approximation of the number of liters of oil that are in the tank at time T equals 15 hours? Right? So we're given this table T in hours and RT in liters per hour, right? And then we're given time t of 4 and 6.5 as our rate, t of 7 and 6.2 is our rate, t of 12 and 5.9 is our rate, and t of 15 and 5.6 is our rate, right? I'm also given the initial condition at t equals 4. There's already 50 liters of oil, right? So this one is asking us to find the approximate amount, right? So we know that this given to us here is a rate, right? And they want us to use 3, right? Riemann sum, right? So that means we're going to need to include 3 rectangles from this thing here, right? So to find the amount, amount is a antiderivative of a rate, right? So we're given a rate, so we want to find the antiderivative of a rate, or in other words, the area, which is why they're having us use right Riemann sums, right? Because that would give us the area of this graph, which would be an amount, right? So if we want to find our amount, that's equal to 50, right? Because we initially start at 50 liters at time t equals 4. And then we need to use our first right Riemann sum triangle, rectangle, right? So to make a right Riemann sum rectangle, right? We need to find our first rectangle, which here has a base of 7 minus 4, or 3 times 6.2, right? Because they tell us to use a right Riemann sum, we want to use the right y value, which in this case is 6.2. Now for our next rectangle, it's going to be between 7 and 12, so our base will be 5 times 5.9, because it's the right y value. And then our last rectangle will be from 15 to 12, plus 3 times 5.6 is 16.8, right? And now we just have to add these together. 50 plus 29.5 is 79.5. So that was 8. Okay, this one is 9. Which of the following series converge? We're given 1 sigma from n equals 1 to infinity of 8 to the n over n factorial, 2 sigma from n equals 1 to infinity of n factorial over n to the 100, and then 3 sigma from n equals 1 to infinity of n plus 1 over n times n plus 2 times n plus 3. Okay, right? So now we're going to want to check to see which one of these are true, right? Okay, so let's see this one, right? So we have a few ways to check if a series converges, right? We have our p-series test, we have an alternating test, we have a comparison test, and then we have like other tests. So here we could use the ratio test, right? Wait, no, that's for, give me a sec. Oh, we can use a ratio test to see if it converges. Oh, that's silly. Oh, yeah. Okay, right? So the ratio test is when we do 8 to the n plus 1 over n plus 1 factorial times the reciprocal, or n factorial, over 8 to the n, right? So this is for 1. So we can rewrite this as 8 to the n times 8 over n plus 1 times n factorial, right? Times n factorial over 8 to the n, right? So we can cancel out these 8 to the n's, right? And actually we should have just left this as n plus 1 factorial. And then we can rewrite this as the limit as n approaches infinity of n factorial over n plus 1 factorial times 8, right? So as n approaches infinity, right? This is infinity over infinity, or 1. So this is just equal to 8, right? Ooh, that's not a good 8. So this is equal to 8. Because we get an actual value here, that means that 1 converges, right? Next, we want to check 2. So 2, same thing, n plus 1 factorial over n plus 1 to the 100 times n to the 100 over n factorial, right? So here, um, if we rewrite this as limit as n approaches infinity of n plus 1 factorial over n factorial times n to the 100 over n plus 1 to the 100, right? So as limit as n approaches infinity, right? Here that would give us infinity over infinity, or 1, and that would give us infinity over here, or 1 again, right? But because we don't get an actual value, this series does not converge, or it diverges, because this is not an actual value. So we know that 2 doesn't work. Next, we want to check 3. Okay, 3. So we're given n plus 1 over n times n plus 2 times n plus 3, right? So we just need to do n plus 1, right? So that's n plus 1 over n plus 1 times n plus 1 plus 2 times n plus 1 plus 3 times the reciprocal, or n times n plus 2 times n plus 3 over n plus 1, right? So we can simplify this of n plus 1, or n plus 2 over n plus 1 times n plus 1 plus 2, or n plus 3 times n plus 4, right? Times n plus 2 times n plus 3 over n plus 1, right? So here, wait, Okay, so we can still rewrite this as the limit as n approaches infinity of n plus 2 over n plus 1 times n plus 2 times n plus 3 over n plus 1 times n plus 3 times n plus 4, right? So this n plus 2 over n plus 1 will be infinity over infinity, or 1, right? And we can cancel an n plus 3 here, and we're left with n times n plus 2 over n plus 1 times n plus 4, right? So we could also rewrite that as n squared plus 2n over n squared plus 5n plus 4, right? So now, limit as n approaches infinity, this would be, that's the same thing as the horizontal asymptote, right? I think, maybe. So then this would be approaching 1, right? So this one converges. Alright, so I don't know, I'm not entirely sure why this one converges and this one doesn't, but that's what the answers say. Oh, wait, so the answers were A, 1 only, B, 2 only, C, 3 only, D, 1 and 3 only, or E, 1, 2, and 3. Alright, and so the answers say that it was D, 1 and 3 only are the ones that converge. This is why I don't like series. Okay, that was 9. Now number 10, we're given the integral from 1 to 4 of t to the negative 3 over 2 dt. We just want to find what this is equal to, right? So we're given a, negative 1, b, negative 7 over 8, c, negative 1 over 2, d, 1 half, and then e, 1, right? So now we're just simply taking the antiderivative, right? So we have the integral from 1 to 4 of t to the negative 3 halves dt, right? So if we have something to the negative 3 half when we take the antiderivative, we'll add 1 to here, right? So we get t to the negative 1 half from 1 to 4. But if we took the derivative, wouldn't we get a negative 1 half t here? To negative 1 half times t to the negative 3 over 2. But because we don't have a negative 1 half here, we know that this has to be multiplied by negative 2, right? So now we just plug in 4 and 1 for t. So we get negative 2 times the quantity of 4 to the negative 1 half minus 1 to the negative 1 half, right? And we have negative 2 times all that. So negative 2 times 4 to the negative 1 half is 1 half, right? Because this is also the same thing as 1 over radical 4. And radical 4 is just 2, so it's 1 over 2 minus 1. Because it's the same thing as 1 over radical 1, and radical 1 is just 1. So that is equal to negative 2 times 1 half minus 1 is negative 1 half, right? Negative 1 half times negative 2 is just equal to, the negative 2's cancel out, right? And we just get 1, or E. Okay, number 11. Okay, let f be the function defined by f of x equals radical, the absolute value of x minus 2 for all x. Which of the following statements are true? And if you guys haven't noticed, some of these problems are the same as questions from the AB stream yesterday, because they give the same questions to both A, B, and BC. It's just BC has some different problems. So we did this one yesterday, but we'll go over it again. So A, F is converges continuous but not differentiable at x equals 2. B, f is differentiable at x equals 2. C, f is not continuous at x equals 2. D, the limit as x approaches 2 of f of x is not equal to 0. And E, x equals 2 is a vertical asymptote of the graph of f. Right? So this here is a absolute value, right? So we can rewrite absolute values functions into a piecewise function. So f of x equals radical x plus 2 and also radical 2. Wait, that's x minus 2. Radical x minus 2 and radical 2 minus x. Right? Because piecewise, I mean, absolute value functions just make whenever anything was negative, it's now positive, right? So when x was less than 2, this would have been negative, right? Because it's an absolute value, we take the opposite of this function, which is 2 minus x, when x is less than 2. And when x is greater than or equal to 2, it's just a normal function because it was already positive then, right? So now we can now it's rewritten as this, right? And now to check if it's continuous in a piecewise function, we need to plug in x equals 2 into here and see if we get the same f value, right? So if we plug x of 2 in here, we get 2 minus 2 or 0. And if we plug 2 into here, we get 2 minus 2, which is 0, right? So we would get the same value, so we know it is continuous. And we also know that the limit as x approaches 2 is 0, so we know this one's wrong. We know C is wrong. And then we know E is wrong because it's not a vertical asymptote there because there's an actual value, right? And a vertical asymptote is when it's like it's where the function is undefined, right? So it's where if this was a fraction, it's where this would be over 0, right? Because it's not a fraction and it's not over 0. When x equals 2, we know it's not a vertical asymptote. So now we want to just check if it's differentiable, right? Because that's the only answer choices left, right? So to check if it's differentiable, we need to first take the derivative of this piecewise function, right? Ooh. 1/2 x plus x minus 2 to the negative 1/2 negative 1/2 2 minus x to the negative 1/2 when x is greater than 2 and x is less than 2, right? So now, to check if it's differentiable, we need to plug 2 into these values again and see if it's the same thing, right? So if we plugged in x is 2 here, right? We can also rewrite this as 1 over 2 radical x minus 2, and this one is negative 1 over 2 radical x minus 2, right? So next, if we plug in x equals 2 to check if it's differentiable, right, we would get 2 minus 2 or 0 there, and 2 minus 2, which is 0 there. So we get equal to 1 over 0, right, and negative 1 over 0, which is undefined. So we know, and if it's undefined, that means it's not differentiable there. So the answer is A. Because if it was differentiable, then that means that the value of the derivative at x equals 2 would be the same, right? But because it's undefined, that's not a value, so we know that's not true. So we know it's not differentiable there, so that means it has to be A. It's continuous there, but not differentiable. Okay, so that was 11, right? So now we on 12. The points negative 1, comma 1, and 1, comma negative 5 are on the graph of a function y equals f of x that satisfies the differential equation dy over dx equals x squared plus y. Which of the following must be true, right? A, 1 comma negative 5 is a local maximum of f. B, 1 comma negative 5 is a point of inflection of the graph of f. C, negative 1 comma negative 1 is a local maximum of the graph of f. D, negative 1 comma negative 1 is a local minimum of f. Or E, negative 1 comma negative 1 is a point of inflection of the graph of f. Right, so all this is asking us is for the first derivative and second derivative, right? So we're given y prime there is equal to x squared plus y, right? So now we know that a local max or min will be where the first derivative is equal to 0, right? So if we had 0 here equals x squared plus y, right? So now we want to see if either of these two equations will make this equal to 0, right? So if we tried this one, 1 comma negative 5, so 0 would be equal to x squared, 1 squared, plus negative 5, right? So 0 equals 1 minus 5, or 0 equals negative 4, which is not true, right? So we know that at 1 comma negative 5, it is not a local max or a local min, right? So now let's try with the other one, right? 0 equals x squared plus y, right? 0 equals x, which is negative 1, squared, plus y, which is 1. So 0 is equal to 1 plus 1, or 0 is equal to 2, right? So that's not true either. So we know that there is not a local max or a local min at negative 1 comma negative 1 or 1 comma negative 5, right? So now we want to look at the second derivative to find the point of inflection, right? So now we're given the first derivative, so now we just got to take the derivative again to find the second derivative, right? So y double prime be equal to 2x plus y prime, right? And we know that y prime is equal to x squared plus y, right? So 2x plus x squared plus y, right? If we sub in y prime as x squared plus y, right? So now we want to check our 2 points, negative 1 comma 1 and 1 comma negative 5, right? So now we want to find where this is 0, right? So 0 is equal to 2x plus x squared plus y, right? So now let's check by plugging in this point, negative 1 comma 1, right? So 0 equals 2 times negative 1 plus x squared, which is negative 1 squared, plus y, which is 1, or 0 equals negative 2 plus 1 plus 1, or 0 is equal to negative 2 plus 2, or 0 equals 0, right? So we know that one's true. So we know that at negative 1 comma negative 1, it is a point of inflection, but let's check and to make sure that B is wrong, right? So 0 would be equal to 2x plus x squared plus y. 0 equals 2 times x, which is 1, plus 1 squared plus negative 5, right? So 0 equals to 2 plus 1 minus 5, or 0 is equal to negative 3, which is wrong, right? So we know the answer has to be E, that there's a point of inflection at negative 1 comma 1. So that was 12. Now 13, right? What is the radius for convergence to the series sigma n equals 0 to infinity of x minus 4 to the 2n over 3 to the n, right? And we're given A 2 rad 3, B 3, C rad 3, D rad 3 over 2, or E 0, right? So now we want to check where it converges, right? Well, what's the radius it converges? So we can check that with our ratio test, right? So we need to plug in n plus 1. So we get x minus 4 times 2 times n plus 1 over 3 to the n plus 1 times 3 to the n over x minus 4 to the 2n, right? Where the limit as n approaches infinity, right? So we can rewrite this as x minus 4 to the 2n plus 2 over 3 to the n times 3 times 3 to the n over x minus 4 to the 2n, right? And we can rewrite this again as x minus 4 to the 2n times x minus 4 squared over 3 to the n times 3 times 3 to the n over x minus 4 to the 2n, right? So now we can cancel stuff out. 3n and 3n cancels out, and then x minus 4 to the 2n and x minus 4 to the 2n cancels out, right? So we're left with x minus 4 squared over 3, right? So we know that our radius of convergence negative will be negative 1 to 1 of x minus 4 squared over 3 to 1, right? Because your radius of convergence has to be between negative and 1 of this ratio here, right? So now we want to solve for x, right? So we can multiply everything by 3. So negative 3 times radical times x minus 4 squared to 3, right? And then we can take the square root of that, right? So I don't know how you do negative rad 3, but sure. Negative rad 3 to x minus 4 to rad 3, right? Wait, 13. Oh wait, turns out I did 12 wrong, guys. I'll get back to that after this one, right? It's 2 or 3 plus 3. Okay, right? And then from here we just add 4, right? So we get 4 minus rad 3 to x to 4 plus rad 3, right? So if we see here, x has to be between 4 minus rad 3 and between 4 minus rad 3 and 4 plus rad 3, right? So if we think about it, right, x is in between these two values, right? So that means here we subtract rad 3 from 4, and here we add rad 3 to 4, right? So then that means that our radius has to be rad 3, right? Because that's the difference, basically. If x was like back here, if x was like 4, we have a rad 3 here and a negative rad 3 there, right? So we would be back with rad 3, and we'd be forward rad 3. So our radius would be equal to rad 3, or c. Okay, back to 12, because I copied that one wrong. Right? It's the points -1, comma -1, and points 1, comma -5. dy dx equals x squared plus y, right? So A was local max with our first point. Let's just call this one point A and this one point B, just for easier to go faster. B, point of inflection at point A, no, at point B. Both of these at point B. C, local max at A. D, local min at A, or E, point of inflection at A, right? And we're looking for which one of these is true, right? So here, again, local max and min, the first row has to be 0, so 0 equals x squared plus y, right? So let's check point A. 0 equals -1 squared plus -1, or 0 equals 1 minus 1, or 0 equals 0. So that means we have something at A, right? So we know it'll either be a local max or a local min, right? So if we know that so if we know at this point it's equal to it's equal to the slope is equal to 0 there, right? We want to find if it's positive or negative on either side now, right? So we also know that the rest of these are wrong, right? So if we plugged in like so if we plugged in our next point, 1 comma -5, right, into our slope, so dy dx equals 1 squared plus -5, right, or dy dx equals to 1 minus 5, or dy dx equals to -4. So that means if x was 1, this would be negative, and that means this is positive here, which means it's a max, or a C. Twelve, 13, 14. Let K be a positive constant. Which of the following is a logistic differential equation? A, dy dt equals kt. B, dy dt equals ky. C, dy dt equals kt times 1 minus t. D, dy dt equals ky times 1 minus t, or E, dy dt equals ky times 1 minus y, right? So now for this problem, you'll have to know what the logistic equation is. And the logistic equation has give me a sec. Right, so the logistic differential equation, well, just the logistic equation is equal to, it's y is equal to L, ooh, that's not a very good L. It's L over 1 plus e to the negative kt, 1 plus ae to the negative kt, right? Right? And so we could take the derivative of this, right? Because that's what we're asking for, to take the derivative of this logistic equation, right? So this is also equal to L times 1 plus AE to negative KT to the negative first, right? So if we took the derivative of that, y prime would be equal to, bring it down, wait, so product rule, right? Derivative of, wait, how did I do this in the first place? Okay, right, so negative L times 1 plus A e to the negative kt to the negative second, right, times negative k a e to the negative kt, right? So this happens because we took the derivative of this whole thing with respect to time, right? Because we want dy dt, right? So that's, you bring that negative one down there, so we get negative L times 1 plus AE to the negative KT to the negative second, right, by subtracting 1. You need to multiply by the derivative of the inside, so that, because this is T, we would get derivative of e to the negative KT would be K e to the negative KT, so in this case, the derivative would be negative K times AE to the negative KT, right? So now we just want to simplify, right? So then this is also equal to y prime is equal to L times K A E to the negative KT over 1 plus A E to the negative KT squared, right? Which is equal to K A E to the negative KT over 1 plus A E to the negative KT times L over 1 plus A E to the negative KT, right? So then we can factor out this k, which is a constant, and this thing here is also equal to L, right? Because, I mean, y, because this is L over 1 plus AE to the negative KT, which is the same thing as y. So if we factor out this k and make that equal to y, we get y prime equals to ky times AE to the negative KT over 1 plus AE to the negative KT, right? So that's also equal to ky times 1 over 1 plus AE to the negative KT, right? And then we can rewrite AE to the negative KT in terms of L and Y, right? So AE to the negative, if we here, right, we can multiply each side by 1 plus AE to the negative KT, then divide by Y, right? And then we could subtract 1, so AE to the negative KT is equal to L over Y minus 1, right? So then down here we get L over Y minus 1, right? And then this thing down here, right? This is almost y, but it's just y divided by L, right? So we can rewrite that as ky times y over L times L over y minus 1, right? And then we can rewrite that as y prime is equal to ky squared times 1 over y minus 1 over L, right? And if you multiply, Okay, right? So we get this because we can factor out this y there, so we could get ky squared times 1 over L times L minus y over minus 1. We can just take that 1 over L times this thing here, so we get 1 L over y times 1 over L, so the L square cancels out and we get 1 over y minus 1 over L, right? Which is what we have here. And then we can multiply, we could take 1y from here and multiply that into this equation, so we get ky times 1 minus y over L, right? So basically, the differential equation is this thing down here. So that's the differential equation of a logistic equation, or E. So in the future, you guys can recognize that now. Okay, so that was 14. Okay, 15. We are given a graph. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 1, negative 1, negative 2, negative 3, negative 4. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. And it looks about like this, right? So the graph of a differentiable function f is shown above. If h of x is equal to the integral from 0 to x of f of t dt, which of the following is true? A, h of 6, so that's an h prime of 6, so that's an h double prime of 6, B, h of 6, so that's an h double prime of 6, which is less than h prime of 6, C, h prime of 6 is less than h of 6, it's less than h double prime of 6, D, h double prime of 6 is less than h of 6, is less than h prime of 6, or E, h double prime of 6 is less than h prime of 6 is less than h of 6. Okay, right? So for this one, we're looking at h and its derivatives, right? So to do that, we'd want to take the derivatives of h, right? So h of x is equal to the integral from 0 to x of f of t dt, right? So h prime of x, we would take the derivative of this, right? And when you take the derivative of an integral, you bring this variable down, so you get f of x, then multiply by the derivative of that variable, which in this case is just x, would be 1. But if it was, say, x squared, we would need to multiply by 2x, but because it's just x, it's just 1. And then we need to take the derivative of this, which is just f of x, right? So h double prime of x is equal to f prime of x, right? And now for this, oh yeah, is what's true. And now we just want to find all these values of 6, right? So h of 6, right? That is equal to the area from 0 to 6 of f of t dt, right? So h of 6 would be this whole negative here area here, right? So that means h of 6 is negative, right? H prime of 6 is equal to f of 6, right? And we see here, if this is f and f of 6 is just 0, so h prime of 6 is equal to 0, and then h double prime of 6 is equal to f prime of 6, right? Or the slope. We see here that the slope is positive, so that means h double prime of 6 is greater than 0. So if we order these in least to greatest, it's h of 6 is less than h prime of 6 is less than h double prime of 6. Or in other words, A. So that was 15. Number 16. Okay, let y equals f of x be the solution to the differential equation dy over dx equals to x minus y with initial condition f of 1 equals 3. What is the approximation for f of 2 obtained by using Euler's method with two steps of equal length starting at x equals 1. So we're given a negative 5 over 4, b 1, c 7 over 4, d 2, and e 21 over 4, right? So for Euler's method, we just take tan lines, right? So we need to find the equation of our first tangent line, right? If we start at x equals 1, we're given this initial point, right? So equation of a tangent line is, in point slope form, it's y minus 3, right? Then now we want to find the slope at x equals 1, right? So we need to plug in 1 and 3 here. So 1 minus 3 is negative 2. So that means our slope at 1 is negative 2. And then we finish the rest of our equation, right? Because the x value starts at 1. And now they want us to approximate f of 2 using two equal steps, right? So from x equals 1 to x equals 2, that's a value of 1, right? And if we want two steps, so you need to divide that 1 value by 2. So that means each step has to be 1/2, right? So if we start at x equals 1, we need to have, our first step needs to be 1/2 more than that. So that means our first step is from y minus 3, is from 1 to 3 over 2, right? So that means our next tangent line will be y minus, we want to, and then to find, and then we use this tangent line here to find the y value of that first step, right? So y minus 3 equals negative 2 times 3 over 2 minus 1, or y minus 3 equals negative 2 times 1/2 times negative 2, or y is equal to 3 minus 1, or y is equal to 2, right? So that means that our first point is 3/2 comma 2, right? So now we want to write the equation of our next tangent line. So y minus 2 is equal to the slope, which is 3/2 minus 2. So 2 is also equal to 4/2, so that means this is equal to negative 1/2 times x minus 3 over 2, right? And now we want to plug in f of 2, so that's y minus 2 is equal to negative 1/2 times 2, which is 4 over 2 minus 3 over 2, right? Or y is equal to 2 minus 1/2 times 1/2, right? Or y is equal to 2 minus 1/4, or y is equal to 7 over 4, which is C. That was 16. Number 17. For x is, oh, okay, I can do this one. For x is greater than 0, the power series 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial minus x to the 6th over 7 factorial plus dot 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 plus negative 1 to the n times x to the 2n over 2n plus 1 factorial, right? So this series basically converts to which of the following? A, cosine of x, B, sine of x, C, sine of x over x, D, e to the x minus e to the x squared, or E, 1 plus e to the x minus e to the x squared. Okay, right? So this thing here, right, doesn't this look like a familiar series, right? Where we have odd numbered factorials on the bottom? So out of the 5 familiar series we know, which are e to the x, cosine of x, sine of x, 1 over 1 minus x, and then arctan of x, right? So e to the x is 1 plus x squared over 2 factorial plus dot dot dot, or is equal to x to the n over n factorial. Cosine of x is equal to, wait, 1 plus x squared over 2 factorial plus x to the 4th over 4 factorial, or plus dot 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 plus, wait, it alternates, right? So minus there. So negative 1 to the 2n minus 1 of x to the 2n over 2n. Right. And this is equal to, wait, it's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial plus dot dot dot. Or in other words, negative 1 to the 2n minus 1 times x to the 2n minus 1 over 2n minus 1 factorial. Or in this case, plus 1 actually. Yeah. And 1 over 1 minus x is equal to 1 minus 1 plus x squared plus x cubed plus dot dot dot, or plus x to the n. And then arctan of x is the same thing as sine of x, just without the factorials on the bottom. So x minus x cubed over 3 plus x to the 5th over 5 plus dot 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 plus negative 1 to the 2n plus 1 over x to the 2n plus 1 over 2n plus 1, right? So now doesn't this series here with odd number factorials on the bottom look like sine of x? It's just that this one is the x is 1 less power, right? So here is x, there is 1. Here's x cubed, there's x squared. So doesn't that just like it would be sine of x over x, which is answer choice C? Alright, so that was 17. Number 18. Right? Ooh, this looks funky. 1, 2. Negative 1. Negative 2. Then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 5, comma 2. Negative 5, comma 2. So, right, this is the graph of f prime. It says the graph of f prime, the derivative of function f consists of 2 line segments, this one here and that one there, in the semicircle as shown in the figure above. If f of 2 is equal to 1, then f of negative 5 is equal to question mark, right? We're given a 2 pi minus 2, b 2 pi minus 3, c 2 pi minus 5, d 6 minus 2 pi, or e 4 minus 2 pi, right? So for this one, we'll use the fundamental theorem of calculus, right? Where the integral from negative 5 to 2 of f prime of x is equal to f of 2 minus f of negative 5, right? So here we're trying to find f of negative 5, right? So using the fundamental theorem of calculus, f of negative 5 is equal to f of 2 minus this integral from negative 5 to 2 of f prime of x, right? Dx. So that means f of negative 5 is equal to, now we want to find this area from negative 5 to 2, right? So to do that, we first, if we're starting at negative 5, we first have a triangle here of height 2 and base 3, right? So that means this is a triangle of area 3, right? Because it's 1/2 times base times height. And then here is a semicircle, and the area of a semicircle is 1/2 pi r squared, right? So in this case, our r is 2. So it's 1/2 pi 2 squared. So 1/2 pi 4, or pi over, or 2 pi, right? But this is negative 2 pi because it's under the x-axis, right? So because the integral starts at negative 5, this here is positive because it's above the x-axis, but then it goes under the x-axis, so that makes it negative. So we have f of negative 5 equals f of 2, which we know is 1, minus, right? Because we had to subtract this integral. And then minus, and this is just equal to 3 minus 2 pi, right? Or it's also equal to 1 plus 2 pi minus 3, or in other words, 2 pi minus 2, which is a. Okay, number 19. Okay. Function f is defined by f of x equal to x over x plus 2. What points x comma y on the graph of f have the property that the line tangent to f at x comma y has slope 1/2, right? Given a 0 comma 0 only, b 1/2 comma 1/5 only, c 0 comma 0, and negative 4 comma 2, d 0 comma 0 and 4 comma 2 thirds, e there are no such points. Right, so here's asking us to find what point x comma y will give us this specific slope, right? Right, so that means that to do this, we'll have to take the derivative and find where the slope of this function is equal to 1/2, right? So that we start off with f of x equals to x over x plus 2, right? So now to take the derivative, we're going to have to use the quotient rule, right? So low, which is x plus 2, d high, which is 1, minus high, x d low, which is 1, over low squared, right? So that's equal to x plus 2 minus x over x squared plus 4x plus 4, right? Equal to 1 over 2, right? Because we want to find where this slope, what point x comma y makes the slope 1/2, right? Okay, right? So let's solve this, right? Oh, my legs. We're given x plus 2 minus x, right? So if it's x plus 2 minus x, isn't that the same thing as 2 over x squared plus 4 x plus 4? Then that has to equal to 1/2, right? So next, we'll want to solve for x. So if we multiply each side by 2 and multiply each side by x squared plus 4x plus 4, right? Actually, there was no need to square it, but anyways, right, we get 4 is equal to x squared plus 4x plus 4, or 4 is equal to x plus 2 squared. So then if we take the square root of both sides, right, we get 2 is equal to x plus 2, or in other words, x is equal to, wait, plus or minus 2, so x is equal to negative 2 plus or minus 2, or in other words, x is equal to either negative 4 or 0, right? So we know that when x is either negative 4 or 0, that's where we'll get the slope of 1/2, right? So now we want to find what points x comma y give us that slope, right? And we know our x value, so we just need to plug x to negative 4 and 0 back into the original equation to find the y value, right? So f of negative 4 is equal to negative 4 over negative 4 plus 2, or in other words, f of negative 4 is equal to negative 4 over negative 2, which is also just equal to 2, right? Then f of 0 would be equal to 0 over 0 plus 2, or it's equal to 0 over 2, which is equal to 0. So our 2 points will be 0, comma 0, and negative 4, comma 2, which is answer choice C. Okay, number 20. For this one, we're given the integral from 0 to 1 of 5x plus 8 over x squared plus 3x plus 2 dx, right? So we could also rewrite this as the integral from 0 to 1 of 5x plus 8 times x squared plus 3x plus 2 to the negative first dx, right? And we're given a ln of 8, b ln of 27 over 2, c ln of 18, d ln of 288, and e divergent, right? So now just looking at the answers, we can tell that it'll probably be an ln, right? And if based on this, we know if we took the antiderivative of this 0 to 1 of 5x plus 8 times x squared plus 3x plus 2 to the negative first dx, right? So we know that if we take we know that this kind of looks like this, right? If we take the derivative, we get 2x plus 3, right? But we don't have that here, right? We instead have 5x plus 8. So that means when we take the antiderivative, right, it'll have to be something ln of x squared plus 3x plus 2 from 0 to 1, right? And if we took the derivative, we would get 2x plus 3 here, right? So now we want to figure 2x plus 3 times what, which will make y is equal to 5x plus 8, right? So if you divide each side by that, y is equal to 5x plus 8 over 2x plus 3, right? Ooh, okay. Okay, right? So another way we can do this is we can split this integral, right? 0 to 1 of 5x plus 8 dx plus the integral from 0 to 1 of x squared plus 3x plus 2 to the negative first dx, right? So antiderivative of 5x plus 8, so that's 5 halves x squared plus 8x from 0 to 1 plus the antiderivative of this one, which would be ln of x squared plus 3x plus 2 from 0 to 1, right? Actually, that should be a multiplied by there. Alright, so plug in 1, we get 5 halves plus 8, right? Because if we plugged in 0, we get 0 plus 0, so that's nothing. Times, and then 5 halves plus 8 is the same thing as 8 is equal to 16 over 2. So that's 21 over 2 times, and then ln of 1 plus 3 plus 2 minus ln of 2, right? So that's the same thing as ln of 1 plus 3 plus 2, that's right, that's 5, minus ln of 2. So that's also equal to 21 over 2 times ln of 5 over 2, which is the same thing as ln of 5 over 2 to the 21 over 2. Wait. Oh, jeez, my legs. Ooh. I'm pretty sure what I just said was wrong. Okay, for one thing, that wouldn't be ln of 5, that would be ln of 6 minus ln of 2, so that would be ln of 3. Ooh. So yeah, this is all wrong anyways. I just saw that mistake there. Okay, let's try it this way, right? So we could also rewrite this integral as 5x over x squared plus 3x plus 2 plus the integral from 0 to 1 of 8 over, ooh, that's not a good 8, of 8 over x squared plus 3x plus 2, right, dx. So then antiderivative of this would be ln of x squared plus 3x plus 2 from 0 to 1. Ooh, no. 2x plus 3 is your derivative. Okay, I don't think I'm going to get this one right, so let's skip it for now. Sorry about that. So after 20, 21, line y equals 5 is a horizontal asymptote to the graph of which of the following functions? A, y equals sine of 5x over x. B, y equals 5x. C, y equals 1 over x minus 5. D, y is equal to 5x over 1 minus x. Or E, y is equal to 20 x squared minus x over 1 plus 4x squared, right? So this one is just asking us basically the limit. Which of these has a limit where as x approaches infinity, y is equal to 5, right? Because the horizontal asymptote just means that as the functions eventually going to approach y equals 5, right? So if we look at these, y equals 5x, if x was infinity, that would also be infinity, right? So we know it's not that one. Here, if this one, x was infinity, that would be 0, right? So no, it's not that one. Here, infinity, if you know how to find your horizontal asymptotes, right, from a fraction, you take the greatest power of x, which in this case is x to the first, so you would have 5x over negative x, so your horizontal asymptote in this case would be negative 5, so no, it's not that one. In this case, your horizontal asymptote would be 20x squared over 4x squared, right? So that should be equal to 5, which is this one. And then for A, right? A is wrong because sine will always be between -1 and 1, right? And if x is approaching infinity, this is just to be the limit as this x approaches infinity will just be 0 here. So that means your answer should be E. '21, '22. Oh no. Whew. Mm, I'm gonna skip this one, guys, because it is a series question, and I do not want to think about that right now. Okay, 23. If P is the size of a population at time t, which of the following differential equations describes linear growth in the size of the population, right? So we're given A, change of P over T is equal to 100. B, dP dt equals to 100t. C, dP dt equals 100t squared. D, dP dt is equal to 200p. Or E, dP dt is equal to 100p squared. Right? So this one, we want linear growth of the population, right? So if this is the size of the population, and we're looking for the differential equation, right? So we want dP dt to be a linear equation, right? So the only one here that will give us a linear equation where would be if this was just some number like a, right? Because if you have a t here, right? Wait. Okay, yeah, so because if you have a t, then it wouldn't be a linear, the graph, this derivative would not be a linear equation anymore, would it? It'd be like here, if you graph a, right, the derivative, it's like this. So that means the original function is like this, right? If you graph something that has a t or a p in it, which could change, it doesn't look like that. It's the derivative would look like this, right? So this would be p prime. And then if this is p prime in this graph, then p would be something like that, right? And that's not linear growth, is it? So that means we know that it has to be just some number a by itself without any t's or p's. So we know it can't be b, d, c, or e, and it has to be a. That was 23. Okay, 24. Let f be a differentiable function such that the integral of f of x sine of x dx is equal to negative f of x cosine of x plus the integral of 4x cubed cosine of x dx. Which of the following could be f of x, right? We're given a cosine of x, b sine of x, c 4x cubed, d negative x to the fourth, and e x to the fourth, right? So this equation, doesn't this look like integration by parts? Where basically you have, what, f of x times g prime of x is equal to, alright, f of x, g of x, f of x times g of x is equal to, if you took the derivative of this, right, it's equal to f prime of x, g of x, plus g prime of x, f of x, right? And if you integrated that, you get f of x times g of x is equal to the integral of f prime of x, g of x, plus the integral of g prime of x, f of x, right? So in this case, we see that, and then you could just subtract that, and you get the integral of g prime of x, f of x is equal to f of x times g prime of x minus the integral of f prime of x, g of x, right? So basically, we want to find in this original equation up here, which which we want to make one of these f of x and the other of these g of x, right? So let's just make this one f of x because it's already given to us as f of x, right? So we know if this is f of x, this is g prime of x, right? If this is g prime of x, then that means this has to be g of x, right? So this is f of x, this is g of x is negative cosine x, right? Because if you took the derivative of negative cosine x, wouldn't you get sine of x, right? And if this has to be f prime of x, and this has to be g of x now, right? Okay, right? Okay, right? So now we see that f of x will have to be something of like x to the fourth, right? So we know it won't be a or b, right? And so now we know that if g of x is just equal to cosine of x, right? Well, here g of x is equal to cosine of x, so this has to be negative f of x up here, right? So we have f prime of x here, right, is 4x cubed, but it should be a negative, right? Because we're given a negative f of x here, right? If g of x is just cosine of x, right? So if g of x is just cosine of x, the derivative of this should be negative. Right, this should be negative f x times g of x. So then to find f of x, we just take the antiderivative of that, right? So the integral of negative 4x cubed should be negative x to the fourth, right? Or d. Wait, 24. Let's make sure I copied this one right. F of x. Okay, well, I just checked and the answer was not that. Let's go back to the top, right? Ooh, that's why, right? So we see that in our normal integration by parts function, right? It's the product of the two functions minus this one, but up here, if we have negative the product plus that one. So if we multiply this whole side by negative 1, we should get the integral of f of x of sine of x dx equals to f of x cosine of x minus integral 4x cubed cosine of x, right? And that should also be negative if we multiply each side by negative 1, right? So then if that's... Alright, so now we see that if we took the derivative of cosine of x, we would get the negative sine of x here. And so if we took the derivative of... And then we see here that this is fine, right? Because if we took the derivative of cosine of x, we would get the negative sine of x. And then that would... wait, we take the antiderivative, right? And then it would be the other stuff, right? I'm getting a bit tired here, but anyways, we just want to take the antiderivative of this one. So the integral of 4x cubed equals x to the fourth, which is e. Yes, right? So that will be the end of today's stream. All right.